Hello and welcome to today's lesson. Today we are going to focus on understanding multiplication of fractions, and we are going to use something like a grid or a square grid, a rectangular grid. Now we are going to solve two questions. One that involves proper fractions, and the second one involves a proper fraction and a mixed fraction. Now, to begin with, it's important to understand that a fraction has two parts. The numerator is the top number and the denominator is the bottom number. For example, for a third, 1, which is the top number, is the numerator, and it tells us the number of parts we are interested in for this fraction. And 3 is the denominator. It tells us the number of parts it takes to have a value of 1. For instance, that denominator being 3 for the fraction a third, it tells us that if my rectangular box here is going to represent my unit, which I assign the value of 1, it means that I am going to partition this rectangular box into 3 equal parts. 3 equal parts. So that's what that 3 being the denominator means. And if this one is going to be my origin and I label it along horizontally, I assign it that corner as 0, my origin. So moving horizontally to the first partition, that will be representing the fraction a third. To the second partition from 0, it will be 2/3. And then finally 3/3. 3/3, which is equivalent to a 1. So for me to be able to show a third in this case, it will simply be this partition here, that part of 1. And that will be representing a third. Now, that 1, which is the numerator again, it is simply indicating the number of parts among your equal parts you are interested in. And in this case is only 1 part out of the 3 equal parts, and that's the numerator. And of course, again, we say the denominator is the number of parts. You can partition that which you assign the value of 1. So in this case, I am assigning the length of my rectangular box here as the value of 1 unit. Now, let us get into our questions now. And because the first question involves multiplying two proper fractions, so we will have the same idea into play. So for a third, for the first fraction a third, I'm going to show it horizontally. And that means with the denominator, I'm supposed to partition horizontally this rectangular box into 3 equal parts. So if this is my origin, from 0 to the first partition, that will represent a third, 2/3, 3/3, which is equivalent to 1. 3/3, it's actually 1. Because I want to show also the other second fraction, I can show it vertically. So I am going to partition again my rectangular box vertically into 3 equal parts. So from 0 downward to the first partition, that represent a third. Then to the second partition 2/3, and 3/3, which is giving us 1. So we have to agree so far that the value of 1 for the whole rectangular box, it will be 1 by 1. It's from here to here horizontally and from here to here vertically. Now, we want to find the final answer. What is a third times a third using this square grid? So horizontally, I need to shade the part or the piece that represent a third. And vertically, it's also only one part vertically that represents a third from 0 to a third. So basically, a third times a third will simply be represented by that one shaded part. Now, how do we tell our final answer? Final answer, which should have a numerator and a denominator. So as we have listed here or highlighted here, is that the numerator is the number of parts we are interested in. And actually that one is given by the shaded parts, And the denominator will be given by the number of parts it takes to have a value of 1. And because we are dealing with a rectangular box or a rectangular array, if you want to say it that way, it's simply the area bounded by 1 by 1 unit. Now, the numerator, the shaded part, is only 1. The denominator are the total number of parts bounded by 1. If I use a different shade here, from here to here, one horizontally and one vertically. How many parts are those? There are 9 in total. There are 9 parts. And so it means that a third times a third equals to 1/9. A third times a third equals to 1/9. Let us do similar thing to the second question. A third times 1.5. Number 2, a third times 2 is actually 1.5. 1.5. Now, this one is the same as, let's agree that in 1, this 2 here, the denominator of our mixed fraction, it tells us that for this fraction, whatever we are going to assign the value of 1 will be partitioned into 2 equal parts. So like this one has 2 halves, 2 halves. So this one is the same as saying 2 halves plus 1 half. And that gives us a total of 3 halves. So this one is simply the same as saying a third times 3 halves. A third times 3 halves. So we want to represent that or to solve that. So we want to show 3 halves, and we have to appreciate the fact that 1.5 is actually a mixed fraction that is between 0 to 2 as a whole number. 0 to 2 as a whole number. So if I want to show 1.5 horizontally, I can have my first partition here, which will be equivalent to my 1. And that means I should have from 0 to 1, I should partition that into 2 equal parts. 2 equal parts. And of course, from 1 to 2, this one should be partitioned into 2 equal parts. So from 0 to the first partition, this one is representing the first half. To the second partition is representing the second half, which is equivalent to 1 whole. And the third partition is representing 3 halves, 3 halves. And that is our main interest, because we are going to multiply a third times 3 halves, a third times 3 halves. Now, to show the third vertically, that denominator 3 tells us partition, vertically into 3 equal parts. So from 0 to the first partition, that represents a third, to the second partition, 2 thirds, to the third partitions, 3 thirds, which will be equivalent to 1. 3 over 3 is 1. 2 over 2 is 1. Now, we want to find the final answer. By the way, the numerator will be the number of parts we are interested in. We are interested in shading the number of parts that takes 3 halves up to here and 1 third downward. So this part here, the number of parts that it takes 3 halves horizontally and 1 third vertically. And that one will be our numerator of our final answer. We are finding the final answer. Our numerator will be 3 parts. So what will be our denominator? Our denominator will be the number of parts that it takes to have a value of 1 by 1. 1 by 1. So 1 horizontally is up to, showing it here, is up to that area, 0 to 1, and vertically 0 to 1 is up to that area. So how many parts takes 1 by 1 area? If you count them, and this one you count the shaded and unshaded, because you're interested with the number of parts that it takes to have a value of 1 by 1 unit. So they are going to be 6 in this case. They are 6 in this case. And therefore, the final answer to our question, a third times 3 halves should be 3 sixths. 3 sixths. If you like it better, we always simplify our fraction, and this is the same as saying a half. This is the same